Hello, my name is Krishnakumar, Naval Architect, formerly with DNV and Indian Register of Shipping. This course is put together for the extra first class marine engineering examination as per syllabi prescribed by the Directorate General of Shipping, Government of India. This module is the first introduction module as per the syllabus. The first module section relates to these subjects, which is the introduction to ship types and the basic aspects of ship design and structures. You can say introduction to naval architecture. But before I do that, I would like to introduce you to the essential aspects of a naval architect's job. Fundamentally, a naval architect starts from the very design concept, which essentially is a brief from the owner on what is the purpose of the ship and what is the cargo this has to carry, what are the range of ports it has to operate, what is the journey type, fundamental design which is part of a pre-contract phase, which is a brief which comes to the naval architect who will have to produce the contract phase from a shipbuilder's perspective. Or if he is working for a shipping company, he prepares the pre-contract documents. Now, shipping is such a vast topic, merchant shipping, and naval architects is not only limited to merchant shipping. It could be involved in warship building, it could be in offshore vessels, it could be in terms of passenger vessels, it could be in terms of harbor crafts. So there are so many wide variety of vessels, but our focus here will primarily be on merchant shipping, which carries cargoes. So the cargoes are also many types. Are they package cargoes? Are there bulk cargoes? Are there break bulk cargoes? Are there liquid cargoes? Or they're containerized? Or special cargo carriage conditions like chemical carriers or liquefied LNG cargoes? There could be fishing vessels. So many types of vessels are there. But shipping is an evolved subject, and there has been a lot of previous designs to fall upon. Further, in the design context, what are the ports and the rivers to which, if there are rivers to be traversed, or if there are special zones to be traversed, it may have an impact on the dimensions of the ship. And the port facilities also has a bearing on the gear that has to be designed on and carried on the ship. Weather conditions, ship speed, installed power, all these factors have to be taken into consideration, and the fundamental basic design must withstand that the ship must be able to float and have enough reserve buoyancy. It should be stable against various forces that cause it to roll and move in a seaway. It should maintain the speed which is designed, which the owner wants to achieve. It should be strong. It should keep the course in terms of, and it should be comfortable to reside on, and economically the ship must be able to ply as well as be safe and reliable. So there's a whole plate of requirements which the naval architecture subject has to stand. It starts with a blank slate almost. Now, I will go a little bit more deeper into this just to give you a flavor of the three phases of design. One, which is a feasibility design or the pre-contract phase, and from there comes to the contract phase. When you come to the contract phase, already the design has been kind of frozen up. The layout drawings have been prepared. The basic equipment like the power estimate, the engine types, the various facilities on board would have already been defined. Because at this point of time, the shipbuilder will have to talk about cost, and the costing calculations have also to be arrived at and agreed on at the contract design phase. Once a contract design is done, the full design phase starts, which is a concurrent process in which the structural designs, the detailed structural designs, the detail engineering designs, the outfitting designs are parallelly being processed. This literally continues for a period till the as-fitted drawings are made when the vessel is completed. So the naval architecture discipline is intimately involved in documenting the entire phases of ship construction. And it's not only with respect to design, the designers are also responsible for defining the sea trials documents, stability testing, the testing of the structural integrity, general quality and shipbuilding standards. So a whole set of documents which are binding on the contract are prepared and approved by the owner. So this is the scope of naval architects and naval architecture job. The next topic in the syllabus is generally about ship types. I'm sure you're very much aware of it, but I will quickly run through just a few pictures just to put the thing into context for whoever is listening, because I'm sure this course will be not limited to only senior marine engineers. I'm sure any other people interested in the shipping profession may also view it. So the ships are of many types, as I mentioned in the beginning. The bulk carrier, they carry the cargo of bulk quantities. They may be carrying sugar, salt, cement, iron ore, phosphorus, stones, and they could be geared or gearless. The container ship, which is the container and port-wise arranged, they are maybe point to point. The containers nowadays, container shipping is very wide. The general cargo ship can carry all kinds of cargo and pipelines, electrical goods, food, steel sheets, and they are versatile. They can go inwards. Or a vehicle carrier can carry a lot of cars. Cars get manufactured in one part of the country and go, so drive in and drive out. And these car carriers are also very popular. The other specialized bulk cargo could be a livestock carrier, which has these live animals within so you could have these are not that common. Similarly, there could be refrigerated reefer cargo. There could be reefer cargo ships which are in reefer cargo containers, but there could be full ships with full reefer cargoes. They carry vegetables, fruits, meats and fish, bananas, etc. There could be fishing vessels. There are many types of fishing vessels, and they are factory vessels. Then of course the crude oil carriers, the crude oil heating system, and the whole set of double hull construction to prevent pollution. So oil tanker is a very large segment of the merchant shipping fleet. There are gas carriers. Different type of gases are carried out, and these are generally going from port to port in a fixed schedules. And there are chemical carriers, parcel carriers, chemical carriers that carry different parcels of chemicals, and there are ore carriers which carry ore. There used to also be an oboe carrier, ore and oil in two journeys, because one way you discharge and you come empty. So these kind of oboe carriers were popular sometime in the past. Of course, there are these passenger shipping, cruise liners, and they are like a 5-star hotel with great luxury amenities. Then there are these offshore vessels, which are many in nature. There is a supply ship, which are the workhorses in the offshore oil fields. There are the diving vessels. There are the platform support vessels. These are platforms, and there are vessels which go and support the platform for the various activities, which these are real workhorses and to work in deep conditions. The next topic is about the internal arrangement and the structural arrangement of various ship types. I have given here a YouTube link which you can watch. There are quite a few videos on YouTube. You can watch them. It gives you a much better feeling of the various different types. Talk about is there are two aspects of structural arrangement, and basically these are all related to keeping the ship afloat, and there are certain standards required for the ship. We all know about the Titanic. Why the Titanic went down, in spite of it being called the unsinkable, there were certain blind spots or weak areas. Now the safety of life at sea requirements talks a lot about subdivision. Subdivision is giving watertight compartments across the ship, And now in case of an oil tanker, there could be, to prevent pollution, there are double hull so that oil doesn't float in. So there are quite a few requirements which have to be fulfilled. There is a concept called floodable length. So what it simply means is that if there is a hole on the ship side, how much of the ship will flood and what will be the reserve buoyancy. And there are certain simulations and calculations to be done. A naval architect has to do these floodable length calculations, and there are 2 compartment standards, 3 compartment standards, and these determine the number of transverse bulkheads that have to be put. The floodable length is the length of the ship that, when flooded, causes the ship to, there is a concept called the margin line, and the margin line, up to the margin line, the vessels can sink, and these are plotted, and what you see here is the floodable length, which is actually the length of the area which can be flooded on the length. So it is plotted along the various length on which area can the transverse bulkheads be determined. And these are approved by classification societies, and this is one of the calculations which have to be done at an early stage in the design. The next, coming back to some of the principles behind this, which could be a little more advanced principles, but it's part of your syllabi. It's the floodable length will again determine on the permeability. Permeability is nothing but if there is cargo in a hold, that will prevent the water coming in. So you have to calculate it with certain permeability conditions. So these are also calculated. So what you see is various permeabilities you have to calculate and display the floodable length. And then the floodable length with a two compartment standard and 1 compartment standard can be juxtaposed to see whether the floodable length, acceptable floodable length calculations are met. These are also part of the design calculations, and class societies normally approve this. Now when you look at the ship structure, there are a whole set of structures. There are transverse structural members. Transverse structural members give the racking strength. So the ships twist in a seaway, and these transverse structural members prevent it from the torsional movements. And there are longitudinal members here, which are what gives the tension. The ship, it will hog and sag, and these provide the structural strength, including the steel plates. So the ship's arrangement is very much determined by the design and also the classification rules, in which it determines on the dimensions of the ship. The initial dimensions of the ship are arrived at based on the cargo carrying capacity, and once these dimensions are fixed, the scantlings or the design thicknesses of various members are determined by the arrangement. So this is how the ship structure gets linked to the design. Hull strength is a very important aspect, because essentially the whole issue of strength is a vessel can become distorted. When a load comes more than what a steel plate can withstand, the plate buckles. It's a distortion issue, which simply means that the force has exceeded the yield point of the steel or the structure on materials on which the vessel's strength bearing member has been designed for. Or it could lead to cracking. A cracking is related to again a failure, but a crack can come not only due to a load getting exceeded, but it can be due to fatigue of the material. There's a process of fatigue where because the ship is on a seaway, it is alternating all the time. So there is a fatigue which can set into this thing. So at a very low yield point, much lower than the ultimate tensile strength, the vessel can crack, and many disasters have happened due to cracks. These cracks can also emanate from certain scallops and holes, which are part of the construction aspects to give air holes and water holes. So these are also sources where fatigue cracks can develop. And then there is this large scale instability which can happen if the pillars fail. You can have a collapse of a structure due to various reasons. And of course, there is always a contact damage which can also cause damages. So the hull strength, there are many types of strength, and these are, and the failure mechanisms. This is a very involved part of the ship design aspects, and classification rules have developed over the years, and they specify it, and there are also now finite element calculations which can simulate the stress across. So what you're seeing here is some kind of a visualization of the various members, longitudinal members, transverse members, girders, and you can see these structures getting constructed on a ship graving yard in a shipyard, and you can see these members. You can see this is a cross section of an oil tanker with a double hull, and you can see the inner tank surface, the double hull surface here. This relates to a general cargo ship which does not have a double hull, but it has got a twin deck space where you can store cargoes. So there are various types of structural arrangements which can differ from ship to ship, but essentially there will be a transverse framing membership as well as the longitudinal framing frames. And that is how the whole strength of the ship is made to withstand the longitudinal bending moment, the transverse bending moment, and torsional bending moment. These are the 3 degrees on which the ship stresses are impacted. Now here what you're seeing is again the continuity of the connecting members. So either in a transverse direction or in a longitudinal directions, you have brackets and members which gets connected so that a box-shaped structure is made. And the strength, the girder is a box-shaped structure. Eventually the ship, though it has got a shape on the outside, all these members must link together in a continuous manner. So if there is, for instance, in a bulkhead, if there is a member coming here on one side of it, and there is a bulkhead, on the other side of the bulkhead there should be another member. Otherwise there's a discontinuity there, and it could be a place for a crack. So during construction phase, these are very practical things which are being checked upon, and it is taken care of in the shipyards. And this may become even more critical when you're doing a repair, where these kind of fine understanding has to be known, that there is a member on the other side, so that continuity is maintained whether transversely or longitudinally. So there are members like beams, stiffeners, grillage. Essentially a grillage structure must be in place, because in a context of ship repair there could be a failure due to a buckling load, and when a buckled panel is removed, the grillage must be in place and it must tie in correctly with the transverse structures. Normally these repairs are overseen by class society people who are trained for these repairs. Now a little bit on the geometry of a ship. There are the sectional areas, so you have some referral plane. This is the center, the longitudinal line is the center line plane. The transverse plane, there's a midship plane and a transverse plane, and there is the other one is a water plane. So you can describe the ship in these 3 planes, any point in the ship. So it's a 3-dimensional model. Any point of the ship can be in terms of its longitudinal center line, or in terms of its midship, and in terms of, at the same time, since the shape of the ship changes across the is the midship plane, on the transverse plane there are what is known as the buttocks. The buttocks are another line which determines the shape of the vessel across a longitudinal contour, because the shapes change. So using such a geometry, the ship's form is designed, and they are actually in a shipyard, they are cut, and the ships are formed and made. You can see here essentially again the ships are determined in terms of stations. So there are various stations on a ship, and the frames are generally located at these stations, And the naval architecture job is fundamentally, in the initial design, is all about determining the geometry of the ship, because the geometry of the ship has got a bearing on the resistance and the propulsion of the ship. This will be a subject of another topic. So making the form and calculating the ship resistance is an important aspect of the design. You can say this is the part of what is known as the resistance and powering of ships. The other aspect relates again to the buoyancy, the stability part. So there is a density has an impact on the longitudinal center of buoyancy and the position of the buoyancy, and what keeps the vessel in stable conditions. And at the same time, the density of the water also has a level to which the vessel will come down and go up. So there are quite a few things in terms of flotation and trim aspects which a naval architect has to address. So these are called hydrostatic calculations, and mainly the calculations relate to doing a sectional area and moments. There are methods in naval architecture where you have to carry the sectional areas of the various parts and the moments to determine whether the vessels will flotation and trim. Nowadays, these are computerized programs are available, and you can get these in a rapid manner. In olden times, for example, when we were studying naval architecture, even if there were computers, we had to do this the manual method, and it used to take a week for us to do these calculations. And even to draw a line, those days we used to use a batten and weights to get the lines in a fair manner. Nowadays, computer programs have hastened the whole process of ship design. Now, as much as the hydrostatic part of the transverse stability, there is the static equilibrium in terms of the trims. Again, it relates to there is another subject on stability. I will cover this at that time, but it is important to understand that the pitching or the trims of the ship happen because of the weight of the ship, the center of gravity, and the center of the buoyancy. This gives the moment which will right in the vessel when it moves away. So the vessel starts getting pitched and trimmed based on the positioning of the center of gravity and the center of. These are aspects which the ship's master is very much in control of because these are dynamic processes. But during a design phase, a naval architect will look at all the varying possibilities and ensure that the metacentric design, etc., meet the various varying design requirements. So this covers the first topic and of the course. I will just come back to the main topics once again. Sorry, I think I have to redo it. So we have covered the entire thing: flotation, trim, hydrostatic calculations, sectional areas and moments. So designing the form of a ship and computing the volume is the part of a classical naval architect's job, and these relate to the initial design of the ship. Thank you very much.